Hello, welcome back. In today's video, we're going to continue our discussion about volumes of revolution about an axis. But again, what we're going to be looking for this time is what happens if we have a region in between two functions and we want to revolve that region right there. So when we looked at the example before, you can look at the previous video. What we noticed was we're going to take the volume of the outside disk and we're going to subtract the volume of the inside disk. And we said, well, because they both have a pi and a dx, we can factor that out. And what we're left with is just the outside radius squared minus the inside radius squared. And that's what we have here in these little formulas right here. This is just kind of a shortcut for it. We have our pi and our dx on the outside because we can factor those out. On the inside, we have our inside radius being squared minus the outside radius. Other way around, messed that up. Our outside, there we go. Our outside radius being squared minus our inside radius being squared. And we can also do this again in the same thing in terms of horizontal, so in terms of y. That's what we have down here. We're just in terms of y if it's horizontal. Again, we have our outside radius squared minus our inside radius being squared. But this time we're in terms of dy. Now, I personally am not a big fan of this of using these formulas because I think this is a very intuitive unit. I think we can probably derive these on our own, which is how I'll continue to do it. But some people do like the formulas, and you're okay to use them as well. All right, so let's take a look here. For example number one here, let's see here. We want to find the volume of the solid generated by revolving the regions about this uh, rational function and the line y equals 3 minus x. We're going to go about the x-axis, so that's nice. Remember, this is telling us we are in terms of x, and we're looking at vertical rectangles here. That's nice. So if I draw it real quickly, if I draw this, my rational function, there it is, there's y equals 2 over x, and my line y equals 3 minus x just kind of looks like this. There they are. And we are going to take this region in between and we're going to rotate about the x-axis. So now let's call why we call it the washer method. If I look at the washer method, if I would revolve this region here, the shaded region, around the x-axis, notice what we're going to get. We're going to get an open little area right here. We're going to get a washer. And that's what I'm going to draw here. I'm going to draw me a washer. And there it is, my axis of revolution down the middle. There's my x-axis. So to get my radii, I have two radii. Notice I have this big radius. This is the outside radius. To get that radius right here, I'm going to do what we did in the previous video. I'm going to measure from my axis of revolution all the way to the outer function, which is my line. There's my outside radius, my rectangle from my rectangle of math. So my outside radius is just going to be the top minus this bottom. And remember, the bottom is always the axis of revolution. So the top is just my line, 3 minus x minus the bottom. Remember, top minus bottom minus 0. So it's just 3 minus x. There's my outside radius. To get my inside radius, same thing. But now this is just a hole. So if I measure from here, from the axis of revolution, to the other function right here, the hole right there, and we're going to get our inside radius. Well, this inside radius is the top function, which is now my rational function, minus the bottom, which is 0, because that's my axis of revolution. And we're just going to write this as 2 over x minus 0, or just 2 over x. Now, if you want to see it a little bit better, what it kind of really looks like is this. Ready? This might be a little bit, whoop, that's not better at all. There we go. It would look more like this. Whoops, I am not doing so hot graphing my rational parent function here. There we go. It could look something like this. There's my shaded region, there's my one rectangle, and there is my other rectangle of mathematics. Remember, this is my outside, and that's my inside. My inside is the hole itself. And if I want to set my volume up, well, my volume is going to be pi radius of the outside squared d, or just h, I guess, minus pi, the radius of the inside function squared h. And I can just write this pi, The radius of our outside is this 3 minus x squared. H, remember, is just going to be dx minus pi. The radius of my inside, that was just 2 over x squared, and again, just dx. And because they both have a pi and a dx, I can just factor all that out. Pi, and what I'm left with is this 3 minus x squared minus 2 over x squared dx. Now, we do have to find the bounds. So we have to find the bounds, and the bounds are just where they meet. So let's go ahead and do that real quick. That's where it does 2 over x equal 3 minus x. Ugh, this is not going to turn out too pretty. We will get 2 equals 3x minus x squared, or x squared minus 3x plus 2 equals 0. And we would factor that at x minus 2. X minus 1 equals 0, so therefore x is just 1 and 2. And there we go. There is our integral. And you can solve that if you feel like it. It's a lot of work, but let's take a look at the next example, and we'll really kind of show you just how fast this goes. All right, so this time I drew my washer. On the next example, I'm just going to do it the old way. We want to find the volume of the solid generated by revolving the region of this parabola, the following bounds, x equals 1, y equals 0, but this time notice we're going about the y-axis. So that changes things for us. We have to be in terms of y. And we are going to be using a horizontal rectangle here. So what I'm going to do is, from my axis of revolution, the y-axis, I am going to draw. Now notice, if I were to revolve this, we would get this big area here, and we would get this little tiny one. We're trying to find the volume of this little disc right here that we want to, and this is a washer. So the best way to go about doing this, we're looking at a washer. So anytime we're looking at a washer, or sometimes I call it the two-disc method, we need the bigger disc, that's the outside disc. So we need its radius. We'll call that the radius of the outside. We need the inner disc as well, the smaller one. So we need the radius of the inside. And that's all we have to find. So to get the radius of the outside, I just go starting at my axis of revolution. I measure out to the function. And if you notice, it's going to put me on this curve right here, this parabola. We are going to go right minus left, so be careful. Now you also have to be careful, we have to change. We have to be in terms of y. So right now it's y equals negative x squared plus 4. Solving for x, we get y minus 4. And let's see here, we will get x squared equals just 4 minus y. So x is plus or minus the square root of 4 minus y. We want the positive because we're in the first quadrant here. So on the right is our square root, is 4 minus y. And on the left here, remember, over here is my axis of revolution, which is again just 0. So this is just the square root of 4 minus y. Then we have to do the same thing for the inner one. So I do the same thing. Starting here on my axis of revolution, I draw it to the closest one. The inner one you can think of like the closest. And there we have it. The same to get the radius. Remember, when I revolve this, we're going to get this little disc right here. On the right, we have the line x equals 1. So we're going to put a 1 here, minus, and on the left, we have our axis of revolution again. Remember, this part right here is always going to be your axis of revolution, which is 0 in this case. So that's just going to be 1. So there's the radius of my inside. If I set up my volume, really quick and easy, pi, we know what's going to happen. We're going to get the radius of the outside squared minus the radius of the inside squared. And don't forget your dy, the thickness of each one of those. Get the bounds. Where do they meet? We want to know where does y equals negative x squared plus 4 equal 1. That's what we want to find out. Where does it equal 1? And if we can solve, sorry, let me take a look here. X equals 1. Sorry, messed that up there. Let me fix this up. There we go. We're looking for the x's meet, right? So notice, remember, we have x equals the square root of 4 minus y, and we have x equals 1. We want to find out where those meet. So we take 4 minus y, the square root equals 1, square both sides, 4 minus y equals 1, therefore y is 3. And we also know y is 0, so we went from 0 to 3. and that would give us our volume right here of revolution. All right, go to the next video. We'll take a look at one more example, okay? And I will see you then.